Welcome everyone. We are discussing properties of definite integral. I have already said this chapter is the most important chapter. In every competitive exam, in each competitive exam, in each board exam, you must get one 4 marks problem. Today I will discuss some amazing problems of definite integral. So look, problem number 1. 0 to 1, tan inverse 2x minus 1 by 1 plus x minus x square dx. What is its value? Now, you know, if we get tan inverse x, cot inverse x, sin inverse x, then we integrate it by parts. But here, argument is not simple. This is, look, large in size. So, we use here properties of inverse circular function. To simplify it, we use properties of inverse circular function. So look, if we consider this tan inverse, so we know from property of inverse circular function, tan inverse x minus tan inverse y, x minus y by 1 plus xy. So, we try to use this property to this particular problem. Now, this is 1 plus xy. So, 1 as it is, x common, 1 minus x. Now, this is x, this is y. So, if you subtract x and 1 minus x and 1 minus x. So, what we are getting? 2x minus 1. So, we can write it as x minus 1 minus x dx. So, this equals to 0 to 1 tan inverse x minus tan inverse 1 minus x dx. So, look this part. This is the most important part, this one. So, 1 plus xy. So, 1 plus x common this. And if you subtract these two, you get 2x minus 1. So, this is tan inverse x and tan inverse 1 minus x. So, you can write it as dx tan inverse 1 minus x dx. Make it 2 part. Now, if only now, if we integrate this one by parts, we get result. But look, there is also another part, tan inverse 1 minus x. So, we try to use properties of definite integral to the second integral. So, you know 0 to a fx dx equals to 0 to a f of upper limit minus x. This is most important property of definite integral. 0 to a. So, first one unchanged, 0 to 1 tan inverse x dx. 0 to 1 x is replaced by 1 minus x dx. finally what we are getting, 0 to 1 tan inverse x dx, and this is also 0 to 1 tan inverse 1 cancel x dx. So you are getting same integral and value is 0. So what is the value? Value is 0. So listen again. Tan inverse 2x minus 1 by 1 plus x minus x square. Our meaning is to simplify the argument using this property. So tan inverse x minus tan inverse y equals to tan inverse x minus y by 1 plus xy. So 0 to 1 tan inverse this. So you can write it as 1 plus x into 1 minus x. And difference of x and 1 minus x is 2x minus 1. So you can write it tan inverse x minus tan inverse 1 minus x. So make it two part and use this property. So tan inverse x cancel, and finally you are getting value as 0. So value of the integral is 0. Now you consider problem number 2. So this is problem of JEE Main, IIT also, and Wbjee. So same type of problem. So I equals to, we suppose it is I, cot inverse 1 minus x plus x square. Now we want to express it in terms of tan inverse. So 1 minus x plus x square dx. So cot inverse x equals to tan inverse this 1 by x. Argument cot inverse x is tan inverse 1 by x. Now use the earlier property, tan inverse 1. So 1 minus x into 1 minus x. This is minus. So relevant property, look, tan inverse x plus tan inverse y equals to tan inverse x plus y by 1 minus xy. Now this is 1 minus x into y. So if we add x and 1 minus x, we get 1. So for 1, we can write x plus 1 minus x. So x into 1 minus x. So this step to be noted. So as of earlier, we can express it as a sum of two tan inverse. Now this is x, and what is y? Y is 1 minus x. So by well-known property, this is tan inverse x plus tan inverse 1 minus x dx. This one. Now 0 to 1, same as earlier, tan inverse x dx unchanged, and this is 0 to 1 tan inverse 1 minus x dx. 0 to 1 tan inverse 1 minus x dx. Now 0 to 1 tan inverse x dx unchanged, and use the property x is replaced by 1 minus x. So x is replaced by upper limit minus x. So finally what you are getting, 0 to 1 tan inverse x dx plus 0 to 1. 1 cancel, tan inverse x dx. So both are in the previous problem, tan inverse x are cancelled out. Now here you have to add. It is plus 2 into 0 to 1 tan inverse x dx. 0 to 1 tan inverse x dx. Now integrate it by parts. So 2 unchanged, 1 into tan inverse x. One is inverse circular and another is constant function. So by Liet rule, you have to integrate tan inverse x. So this is first function, this one is second function. So tan inverse x into integration of 1, integration of dx minus d dx of tan inverse x integration 1 into dx and total dx. So no need of writing this part because it is problem of competitive exam. So dx is x tan inverse x minus x by 1 plus x square dx. So integration dx and derivative of this. So 0 to 1. Now 2 into x tan inverse x minus half log 1 plus x square. It is problem of definite integral, so you have to put here 0 to 1, or you can write this one. Now put value of upper limit and lower limit and simplify. So 2 into, if we put 1, tan inverse 1 minus half log 2, putting upper limit 0, so 0 minus half log 1, so log 1 is 0. So finally what we are getting, you look, finally what we are getting. So 2 into pi by 4 minus half log 2, and this one is log 1 is 0. So pi by 2 minus log 2. So option B is correct option. Option B is correct option. So cot inverse 1 minus x plus x square. Argument is, look, bigger in size. So do not integrate it by parts. Try to simplify it, then integrate it by parts. So problem number 3. Now problem number 3. So tan inverse, same problem, but it is in terms of tan inverse. You know, integral of cot inverse, same argument. So there is a relation tan inverse x cot inverse x equals to pi by 2. X can take any value. So we know integral of cot inverse this. So we can write it as pi by 2 minus cot inverse 1 minus x plus x square, then dx. Now this one is 0 to 1 pi by 2 dx, 0 to 1 cot inverse 1 minus x plus x square dx. So it is pi by 2 outside, integration dx, that is x, and this is, by previous problem, value is pi by 2 minus log 2. So finally, if you put value, you are getting value as log 2. So I have already said that if we use this symbol log, we suppose base is a, ln also a, log also a. So what is the value? Value is log 2. So this is direct application of result 2. So option A is correct option. So today I have discussed 3 important problems, amazing and interesting problems of definite integral. So these are most important for competitive exam. So thank you for today.